So welcome to Eye in the Future Forum 2020. We're super excited to have everybody here. My name's Jess Gibbetson. I'm the Vice President of Clinical and Development Operations at ProQR. Just wanted to start with a few housekeeping items. Our forward-looking statements for you to take a look at. And just before we get started, wear your badges. The color on the lanyard will tell you what breakout sessions that you'll be attending. If there's an emergency, please leave through the designated exits. Mobile phones to silent mode, please. There are hand sanitizers throughout the room, so feel free to use and overuse those. We are on social media. Feel free to use your own social media channels on Twitter, Eye in the Future Forum hashtag. And we are streaming live on YouTube for this main session. If you have a question, there will be a question and answer period. Please wait till someone comes around with a microphone. The hotel checkout time for tomorrow, 11 a.m. And we have tried to make this event as accessible as possible for everybody. We're still learning, but we would love your feedback. So as we have more events, we really want to make sure that everyone is as comfortable as possible. So please find a member of the ProQR team if you have feedback, because we'd love to hear it and incorporate it into future events. We have a fantastic Eye in the Future Forum website. If you haven't checked it out yet, I highly suggest you do. We have a format, a regular format, and then a black and white contrast for those that prefer that. And on the back of your badge, you will notice a QR code. And this, if you use this with your phone, this will take you directly to the program for Eye in the Future. And this main forum will last until 3:30, which will be followed by a 30-minute coffee break. We'll do some breakout sessions, and then we'll have an off-site dinner. Please meet in the lobby at 6:30. A bus will take us to a nearby off-site dinner space. And with that, I'd like to welcome Daniel DeBoer, who's our CEO.
Mike. Good morning, everyone, and welcome to this year's Eye on the Future Forum in Paris. We have with us here in the room over 100 people from more than 50 different organizations, with people from the patient community, people from the scientific community, and the medical community, all dedicated to improving the lives of people that live with inherited retinal diseases. I want to especially welcome Rebecca Alexander, our keynote speaker of today, and also Molly Watts, Russell Wheeler, and Isabel Odo, who will be leading the breakout sessions and will be participating on the panel. I also want to welcome the online participants that are following us through the live stream on youtube.com, who are following this main part of the session with us today. So this Eye in the Future Forum coincides with Rare Disease Day 2020, and that's not a coincidence. We started this company 8 years ago on a mission to develop medicines for people that live with rare diseases where no treatment option is available. And right now, we're mostly focused on the development of medicines for inherited retinal diseases like Leber's congenital amaurosis, Usher syndrome, and retinitis pigmentosa. So our journey started in 2012, about 8 years ago, when we started ProQR Therapeutics. I started this company because one of my children was born with a rare genetic disease that had no treatment option available at the time. And this led us to starting ProQR on a mission to develop medicines for people that suffer from rare diseases and have no treatment option available. And although we started initially with cystic fibrosis, we initiated our inherited retinal disease work soon after starting the company. This is when we partnered with Dr. Rob Collins at the Radboud University in Nijmegen, the Netherlands. And Dr. Collins had invented a molecule, an RNA molecule that could target the most common mutation in Leber's congenital amaurosis. We partnered with Dr. Collins to further develop that molecule to what today is sepofarsen and in our clinical trial Illuminate. We recently, fairly short after that, we expanded the partnership with the Radboud University to include a molecule for Usher 2A. This is a molecule that was invented by Dr. Erwin van Dijk, and this molecule is targeted towards the specific mutation that people with USH2A live with in the exon 13 gene. So then in 2015, we were ready to start development of this first molecule, QR110, which is a molecule that today we call sepofarsen. We started the trial for this molecule in 2017, and then in 2018, we got to take a first look at the clinical data that was emerging from that trial. And what we saw in that interim analysis of that clinical trial was that there was a significant improvement in the vision of people that were participating in the study across multiple people that were in the trial. And some of these improvements were so remarkable that they improved from not being able to see at all at the start of the trial to now being able to read after treatment with sepofarsen. We thought that this tremendous improvement in vision was such an encouragement and such a reinforcement in our belief that RNA therapies, the type of medicines that we're developing at ProQR, could make a real impact across inherited retinal diseases. So with that, we expanded our work in inherited retinal diseases, and we started the development of QR421A, which is our molecule for the exon 13 mutations in Usher syndrome. We teamed up with the Foundation Fighting Blindness that provided us with additional funding that allowed us to start a clinical trial that is currently ongoing in both Europe and the US. And we expect that this trial will start to generate initial clinical data over the course of this year and next year. And then we partnered with Ionis Pharmaceuticals on QR1123, which is our newest molecule in clinical trials that is designed to treat the underlying cause of a specific form of retinitis pigmentosa. So we have started the trial for that recently, and with the start of that trial, our company is now fully dedicated to the development of medicines for inherited retinal diseases. And with that, we have our plate full. We have a whole range of clinical trials ongoing in inherited retinal diseases, including the trial Illuminate for Leber's congenital amaurosis, the trial Stellar, for which we are studying QR421A in Usher syndrome, and our Aurora trial, in which we are studying QR1123 for this specific form of retinitis pigmentosa. Our preclinical pipeline, we continue to expand and continue to invent new molecules in the lab that work in a very similar way, but then targeted against another mutation. And in these pipelines, right now, we have about 25 different molecules that target different mutations in inherited retinal diseases that we hope in the future to advance to clinical trials and to patients. So all of this is possible due to the deep partnerships with a diverse set of people that are a part of our community. And that's what we bring together here at EFF. A group that, together we are furthering our shared mission to help people that live with inherited retinal blindness around the world. So we're here with people from academic institutions that invent new molecules in the lab and learn more about the underlying genetics of diseases, with investigators and clinical trial sites that work with patients and people living with IRDs on a daily basis, and with patient organizations representing the people that live with IRDs and representing their voice in everything that we do. And with this community, we are blazing a trail. We're blazing a trail to educate people on diseases, to identify mutations and genotype, to create awareness and work together to drive clinical development of new medicines for people living with IRDs. All together, patient advocates, healthcare professionals, and drug developers. And with that, we're forming this great community that's here today, together here in Paris at the Eye on the Future Forum 2020. So together, we aim to develop and get therapies to the more than 2 million people around the world that live with inherited retinal diseases. Today, only a very small group, you can barely see them on the screen, a very small group have access to a therapy, and the vast majority of patients that live with an IRD have no treatment available that targets their underlying cause of their disease. And we here today, together in this room, we intend to change that. At ProQR, we started a whole range of programs that, across these programs, aims to help over tens of thousands of people that live with inherited retinal diseases. As our Executive Vice President of R&D, David Rodman, will share with us later today, we anticipate in these first series of drug development programs to learn so much about RNA therapies in inherited retinal diseases, that in the future we can really accelerate the development of medicines for these diseases, to get more medicines to patients quicker, with the ultimate goal to get as many of these patients on a therapy that help with their inherited retinal disease. And to accomplish that, we've formed this pipeline with the most advanced programs that we have in our company ongoing. The most advanced trials are listed on this slide, with the Illuminate trial that we will further zoom in on across the next day and a half here at EFF in Paris. Illuminate is our pivotal trial that's ongoing for LCA10 patients that suffer from Leber's congenital amaurosis type 10 due to the most common mutation, the P699X mutation. And in this study, we are studying sepofarsen, which is our lead compound for that mutation, in a pivotal study. And this study is taking place in Europe, in the US, and also in Brazil. Then we will be talking about the Stellar trial. Stellar is our phase 1/2 study in which we are exploring the safety and efficacy of QR421A for patients that are affected by Usher syndrome type 2 due to a mutation in exon 13 of the USH2A gene. And this is a trial that runs in Europe and the US. And then our third most recent trial is called Aurora. In Aurora, we are studying QR1123 for the P23H mutation that is causing an autosomal dominant form of retinitis pigmentosa. So for the next few days, we'll talk a lot more about these trials and how we can drive awareness for these trials and execute these trials to get these drugs available to patients as soon as we can. And to further support that awareness, we've recently partnered up with the Foundation Fighting Blindness and with Blueprint Genetics to further a genetic testing program that is called My Retina Tracker. My Retina Tracker is a no-cost genetic testing program that's available to people living in the US that are diagnosed with an IRD to actually get their genotype and mutation identified such that people can learn if there is maybe trials available for their mutation or hopefully in the future therapies available for their particular form of inherited retinal disease. At ProQR, we know that the journey to get a diagnosis for a rare genetic disease can be a very lengthy journey. And we also know that this brings a lot of uncertainty for people living with a rare disease and for all their loved ones around them. And with this program, we aim to reduce that uncertainty and get people to the right diagnosis as soon as possible. So for people living with IRDs and for healthcare professionals, if you want to learn more about this program, you can visit the website of FFB or Blueprint or go to proqr.com/genetic testing. So with that, I want to thank all the participants here in the room and online for being here with us at EFF 2020. I look forward to the next day and a half, which promises to be a very exciting program with a multidisciplinary set of topics that we will address. I look forward to sharing experiences with each other, to learning from each other, to together elevate our community, all with the goal to develop medicines for patients with inherited retinal diseases. So with that, it's my pleasure to introduce you all to Rebecca Alexander. Rebecca is our keynote speaker of today. And Rebecca is not only the author of Not Fade Away, but also a psychotherapist, a group fitness instructor, an advocate, and an extreme athlete that is born with Usher syndrome type 3. Rebecca's keynote today is called Living with Usher syndrome. And please join me in welcoming Rebecca to the stage. Can you grab my arm?
Thank you. Okay. Thank you. Hi, everybody. Okay. So just so that nobody's worried about me, I realize that this is the end of the stage. And I'm not going to stand in front of this unless I did want to do one of these. Okay. So I'm Rebecca Alexander. I have Usher syndrome type 3. And if it's okay with you guys, I move around a lot, mostly because I have a difficult time sitting still or standing still. But so I may go off the stage a bit and walk around. And that's mostly to make sure that I'm not completely boring you. So That's me. So I am these things. Okay, so for those of you who are unfamiliar with Usher syndrome, and hopefully most of you in this room are familiar with Usher syndrome, considering that's why part of why we're here today. I just want to give you a very brief overview of what Usher syndrome looks like in terms of the three forms, and where I sort of end up on this scale of people with Usher syndrome. So just a very quick overview, particularly for those of you who are not familiar with all three types. There are three types of Usher syndrome. A person living with Usher syndrome type 1 is born completely deaf and is progressively losing their vision. Their vision loss tends to have a more rapid decline. It starts to really happen in their adolescence and teenage years, and they generally tend to have balance issues. A person with Usher syndrome type 2 experiences they're born with hearing loss, generally have a set amount of hearing loss that really doesn't progress so much, maybe sometimes later in life. But overall, through the course of their lives, generally have pretty stable, consistent hearing loss, and they experience progressive vision loss. And then a person with Usher syndrome type 3, what I have, experiences the mildest onset of both progressive vision and hearing loss. So I was diagnosed with retinitis pigmentosa at the age of 12. I had difficulty seeing the blackboard at school when I was growing up. I told my dad that I thought I needed glasses. They took me to an optometrist. The optometrist said that there was something in the back of my eye that they couldn't identify what it was because their equipment was not sophisticated enough. And so they sent me and my family to several ophthalmologists. I was born and raised in the San Francisco Bay Area. We went to, for those of you from the US or even who are familiar from outside the US, we went to UCSF and we went to Stanford, and I went through a whole series of tests. And in my mind as a 12-year-old, I thought all of this just to get glasses. And later, the diagnosis was confirmed both at UCSF and Stanford that I had retinitis pigmentosa, and my parents were told that by the age of 30, I would likely be completely blind. So how do you tell a 12-year-old who really, for all intents and purposes, can see that they will be blind as an adult? And my parents had somewhat different approaches to it. My dad really wanted to shield me from hearing the B word, blind, right? And so he had all of the information sent about the Foundation Fighting Blindness at the time. That was really all that existed for us to have information about inherited retinal degenerative diseases. And my mom really wanted to expose me to what was out there, to the community, to develop familiarity with people who had vision loss. And really what they told me at the time in terms of where I was that when I went out at night, if I saw a movie, I would need to hold on to a friend or a family member's arm. I often tripped over the dogs or basically anything below me, and I generally felt like I was pretty clumsy. I had two brothers who I always tried to keep up with. They were very, very active, and oftentimes just felt like I was just sort of a clumsy person in general. But at the time, we only knew or believed that I had retinitis pigmentosa. And this was early on before I'd really experienced my diagnosis. This was me pre-retinitis pigmentosa, pretty normal looking, except if you notice, my brother has really cool tortoiseshell looking glasses. And that's exactly why I put that photo in there. Okay, so today, what does my vision look like? So I was told I would be completely blind by the age of 30. I'm now 41, and I have somewhere between about 10 to 15 degrees of my centralmost vision. So a normally sighted person, when looking straight ahead, has about 180 degrees of vision, and I have just about somewhere between 10 and 15 of my centralmost vision. So despite many of you in this room working with vision loss and seeing retinal IRDs all day long, I'm encouraging you to take your hands and make O's and put them over your eyes. We're all doing it. We all look ridiculous. It's fine. And try to make those O's a little smaller and look up and look down and look around and try to imagine what it might be like to navigate your life, your day, with vision only looking through sort of these small holes. So for many of us, we know that retinitis pigmentosa causes tunnel vision. There's also a smaller group of us within that RP population that have donut vision, and I have donut vision. So what is donut vision? Donut vision means that I have my centralmost vision, and I have this sliver of vision on my outermost periphery. And the donut is everything that I can't see within that. So I'm going to try to give you a sense of what that looks like. Remember that my vision, depending on the environment, depending on the lighting, can be better or worse. But the gist is that I see my hands here. Mostly I see my bracelet, okay? I can't see my hands, I can't see them, I can't see them, I can't see them, I can't see them, I see them. It's hard to explain to people what that looks like, although people are always freaked out when I see them coming out of the corner of my eye because they think that I don't have vision there. So that kind of is a fun party trick that I have. So more importantly, how cute is my dog? I always have to use her for this because she has to get in my slideshow somehow. Okay. So I went to the University of Michigan for undergrad. If it's okay with you guys, I'm going to stop. Don't worry, everybody relax. I'm going to make it. Thank you. Okay, I don't want to stand in front of that light. Mostly I'm coming down here because that light is kind of giving me some distraction. Okay, we can see me okay, right? Great. Okay, so I went to the University of Michigan in Ann Arbor. Anybody that went to the University of Michigan here? Really? All right. There's always a Wolverine somewhere. Okay, so for those of you in Europe, when you find someone who went to the same school as you did, it's a lot of fun. I don't know why we Americans are strange that way. So at the University of Michigan, I woke up one day and I had really loud ringing in my ears. And the sensation was that I couldn't hear people speak to me over the ringing. And for those of us who are familiar with it or have experienced it ourselves, it's known as tinnitus or tinnitus. Oftentimes war veterans who have returned from combat and have been exposed to really loud sounds, they experience tinnitus. If you have gone to a really loud concert and you leave and you have that ringing, that's essentially what it sounds like. And for me, I had it all the time. It never stopped. I woke up, I slept, and I always had the ringing. And it was very overwhelming because it felt like I couldn't get away from it. So I went and I saw an otolaryngologist at the University of Michigan, and they did another series of tests, and they said, Rebecca, you don't just have RP, you have Usher syndrome. We've never seen it as it presents itself in you, but because you have both progressive vision and hearing loss, it can't be anything else. And so it was actually my own family's blood work and a lot of research and trying, not only research, just actually medical research, but research and trying to find people, communities around the world that were living with similar symptoms as I was to identify Usher syndrome type 3. And my mom happened to find a researcher in Helsinki, Finland, named Eva-Maria Sankala, and she was conducting research on a very small population of people in Finland who had the same symptoms as I did. And my family, we sent our blood work, my immediate family sent our blood work to Finland, and it turns out that we were the missing link. And so Usher syndrome type 3 was identified, and I am case number 1. Ta-da! Whoops, I just dropped that. Thank you. Oh, I see it. That felt good. Okay. So we found out that I have Usher syndrome type 3 about 10 years after I received the diagnosis of having Usher syndrome of some form. When I was growing up, people said, so you never had hearing loss before then? Well, I actually did have some hearing loss, but we thought that it was because I had frequent ear infections. I oftentimes watched television when I was growing up out of the side of my left eye, and we just thought it was a funny quirk of mine. We didn't really know that as it turns out, my left ear was my stronger ear, and that was my way of overcompensating for not being able to hear out of my right ear. My right ear for most of my life was pretty much just decorative. It could wear earrings, but it couldn't really give me a lot of information. So, one summer when I went home to California, and I found out that the Department of Rehabilitation in California offered free cane training and a free cane, and I was eligible because I had vision loss to get a free cane and free cane training. And of course, at the age of 20, 21, I thought getting anything free was cool, even if it meant a cane. I'm not sure why. But I do want to be very clear. I think that people often think like, oh, wow, at 21, soon after her diagnosis, she was so comfortable with her diagnosis that she decided to go do her cane training. And that could probably not be further from the case. I was definitely curious about it. My mom certainly had a lot of negotiating with me to get me to do it. But just to make sure that everybody understands that I wasn't going to do my cane training so that I could get out in the world and start using my cane, I drove to my cane training. So for those of you who have never seen someone park their car and then unleash their cane, I've never seen it, but I have done it. And so I did my cane training, and I thought, wow, that's miserable and something I never want to use. So I took my cane and I folded it up and I put it back in my junk drawer and went back to the University of Michigan. I did everything in my power to avoid and even deny what was happening to me. I mean, it was such a big diagnosis that I couldn't even wrap my head around, that I figured if I could make myself as academically perfect and as physically perfect as possible, that nobody would know that there was anything wrong with me, that nobody would know that I had flaws or that I had shortcomings. And so that was my superficial way of trying to come to terms with a diagnosis that was really overwhelming. So I did everything in my power to avoid showing people that I had hearing loss and vision loss. And so much so that I remember going to class one day. Now, for those of you who are unfamiliar with the University of Michigan, they have a very strong football team. And I had a class with a lot of football players in it. And we were playing our rival team that weekend. And I wanted everyone to see how much school spirit I had. So I had my Michigan shirt on, and I had my Michigan hat on, and I put my hair in a ponytail. But of course, I didn't wear my hearing aids because my hair was back, and I didn't want anyone to see that I had hearing loss. So I went to class, and I heard absolutely nothing. And I remember leaving that class and thinking to myself, first of all, I was so lucky that the professor didn't call on me, but if I'm being completely honest, I have no idea if she did because I didn't hear anything. And I also remember feeling like the only person who's being put at a disadvantage here is me, that I was then putting myself at a greater disadvantage just to avoid showing the world or allowing them to see that I had a disability, especially kids my age. It was a really difficult time for me to try to navigate how to live with pride and have both vision and hearing loss. And so it led me through a series of different ways in which I figured I can cope with this and make my life work and still not have to go deaf and blind. So let me go back here. Okay, so before I move on to this, so I decided when I was in California, I moved there actually after college. I was supposed to go and do a program overseas in Africa, and similar to what we're dealing with right now with the coronavirus, we had, they had a breakout of dengue fever, and the program was canceled, and I had to figure out what I was gonna do. So I moved to Los Angeles. My twin brother was living there. They needed a roommate, and I said, all right, I guess I'm going. Now, for most people with vision loss, it's always around daylight savings, particularly, well, in the US, when we feel like we've lost more vision, where we feel like we're struggling more, where we feel like we start to notice what we're having difficulty with. And I am no exception to that. Every time around daylight savings, that time of year, which is November-ish, I always am much more aware of what I'm not seeing or feeling like I'm not seeing as well. And it's always the time where that whole cane idea starts to come around again. And so it was around daylight savings when I was working in Los Angeles. At the time, traffic was terrible. We didn't have ride sharing. There was no Uber or Lyft. You really had to use your own car to get around. Now, I always drove during the day. I never drove at night. But I remember telling my boss at the time that I needed to come into work early and leave early because I needed to get home before it was dark. And so one day I was driving home, I hit terrible traffic, and just before I made it home, I was watching, as I was on the freeway, I was watching the sun go down, and I was starting to feel really unsafe. I knew that it was not safe for me to be driving, and I knew that this was not sustainable, living in a place where I had to rely on myself to drive everywhere, and that at night I was sort of useless, that I would have to rely on other people. And so it was that one evening that I drove home where I made it back to our apartment just in time as the sun went down, that I decided that I needed to go find that cane that I'd been trained on several years before. And so I got my cane, and I went out to the street, and nobody was home. My brother and our roommate, they weren't home yet. And I remember I went out to the street, and I walked myself to the crosswalk, and I just felt like I needed to practice with it a bit more, that this vision loss thing, maybe this really was real. Maybe there were things that I needed to do to try to help myself to live more independently. And so when I got to the corner of the street, I saw a man pull up in his car with his headlights beaming forward, and it was quite dark. We lived on a street that had a lot of trees and branches, which made it even darker, and there was not a lot of street light. And so as I saw him sitting there at the stop sign, I willed him to keep driving, but of course he saw a woman standing there with a blind person's cane, and he probably wanted to make sure that I got across the street safely. So I took a deep breath, and I made my way into the crosswalk in front of his car, and I remember feeling the beams of his headlights illuminate my entire body. And so by the time I'd reached the other side of the street, my face was streaming with tears because it was my first announcement to the world that I was blind, that I had a disability, that no matter what else there was about me that made me unique and different and maybe even special, that first and foremost, people would treat me based on whatever their preconceived ideas were about people with disabilities. And I absolutely hated it. And it was because of that that I said, I gotta get out of Los Angeles. I need to move to New York City. And I decided I needed to move to New York City because I felt like I would be in the same boat as everybody else. I would take public transportation, the subway, buses, cabs, you name it, and that most people didn't drive there, and that it wouldn't be such a difficult place for me to live independently. So as I was preparing to move to New York, I should also mention that I wanted to go into the field of social work and public health, and so I applied for graduate schools in New York, was fortunate enough to be accepted into a few programs. And as I was preparing for that move and really dealing with the difficulty of living in a city where there was no real accessibility for people like me, I decided to start training for a big bike ride. So the bike ride was known as the AIDS Life Cycle Ride. This was in probably 2001. And at the time, there was still a lot of research that was being conducted to help HIV/AIDS. I was always very active in the HIV/AIDS community when I was growing up, and mostly because I'd heard a speaker speak to me about living with HIV, and I think at the time I hadn't realized that there was so much that he said that resonated with me in terms of uncertainty and not knowing what his life would look like. And whether I knew it or not at the age of 14 when I heard him speak, I definitely knew that there was something that really kind of resonated, and I didn't want to just sit around and hear this story and be touched by it. I wanted to do something. So I decided to do this ride, and I also knew that I didn't know how much longer I would be able to ride a bike independently. One of the things that I haven't mentioned here, but that I should just mention briefly, is that when I graduated from high school, I was in a very serious accident. And I was told by doctors that I would never walk properly again. I shattered my left foot, I shattered my left hand, I broke my right hand, I broke my back. And so basically the only thing that this was my first real experience of what it meant to live with a disability, because I was in a wheelchair for about 4 months and I had to rehabilitate myself. And the only thing that I had at the time was my right leg. I had to learn how to do everything that I needed to do to get around only using my right leg in a wheelchair. So I was sort of scooting myself with one leg. And was not released from the hospital until I could efficiently get myself up out of bed, into a wheelchair, and out the door in case of a fire, with only my right leg. So that's probably why I was there for a month. It took me about that much time to get that down. But so part of my recovery from that accident was, well, wait a second. I was only 18 when I had that accident. I need to make sure that I can really get my strength back and rehabilitate myself. And so part of that was becoming physically active and more physically active. And I think at the time, I didn't really understand that also strengthening my body during that time that I had to recuperate was also a way of giving me a tremendous sense of control, a tremendous sense of ability to do something when I had a condition that I had absolutely no control over, right? So one day we were going down, it was about a 600-mile bike ride. It was a week long. We went from San Francisco to Los Angeles. And on one of the final days, we went down the Pacific Coast Highway, which for those of you who are unfamiliar, rides along a cliff where there's just crashing waves and rocks, and it's absolutely breathtakingly beautiful. And on the other side, there are cars that are going 60 and 70 and 80 miles per hour. I'm trying to do the kilometers in my head, and I can't think it through yet. Can you remember that one, Alan? Okay, I'll let you guys do that. So as we were riding, there was no bike lane. We had to actually make a bike lane. We had to create a space for ourselves to ride in between this cliff and in between these cars that were racing and going as quickly, as they could down this beautiful highway. And I remember riding, knowing that I had about 30 more miles to go, and wondering to myself, I was scared. I didn't know, well, what kept me from just veering off the side of this road and down this cliff into the ocean? Or what kept me from veering into traffic when I really just had this much space to ride? And in those moments, oftentimes, particularly when we live with any condition that causes us to either lose our senses, whether we live with anxiety, remember I'm a psychotherapist, when we live with depression, when we live with any condition that can be debilitating or that can have an impact on our ability to live our lives comfortably or effectively, our brain can really sort of take us down a rabbit hole. And so in that moment, I came up with this self-imposed way of coping with my fear, and I came up with a mantra. And the mantra is, breathe in peace, and I would breathe in through my nose, breathe out fear. Breathe in peace, breathe out fear. And obviously it worked because I'm standing here today. But it is a mantra that I use even to this day, particularly as since that time, 20-something years ago, I have lost a lot more vision and hearing than I even had at that time. And it really has been somewhat of a saving grace for me. So I moved to New York City. And as it always does, daylight savings rolled around. And I remember there was one night when I was walking, and I was still not comfortable yet with this whole cane idea. And I was walking to one of my best friends. I just come out of a hair salon. I got my hair blown out. I was going to my best friend's 40th birthday party. And in New York, we have those cellar doors. And I fell right down one of the cellars. I didn't see it. And it was a dark and a rainy night. And it was pretty scary. I was pretty banged up, had some gashes, and was pretty bloody. And I realized that I probably needed to start carrying my cane with me when I went out, particularly at night. And so I started carrying my cane, and it was probably about a year later or so, when daylight savings came around again, that I was walking down a street that I was certain was unobstructed, and I slammed straight into a steel gate. And I was certain that there was nothing in front of me. So you can imagine the shock of, first of all, running into something, and two, the pain of running into something that you were certain was not there in the first place. And so I realized that using my cane or carrying it with me was not enough, that I actually really did need to use it. And so when people, particularly in this community who have RP, who have Usher syndrome, ask me, well, so how did you decide that you needed to start using your cane? Well, that's how I decided that I needed to use my cane, because I was putting myself in danger, even in times when I didn't realize it. And then they say, and so when you started using your cane, did you feel good about it? Did you feel comfortable? And the first 4 or 5 or even 6, maybe 7 times I used my cane, I cried, which, you know, listen, when you live in New York City and you're using a blind person's cane and you're walking down the street and you're crying, it doesn't draw that much attention. It doesn't look that unusual. There's a lot of weirder stuff happening in New York City, as you know. So, but I do remember the night when I was walking down the street and I waited for the stoplight to change, and it changed, and I made my way across the street, and I got to the other side, and I remember feeling like, oh my gosh, I'm not crying. And not only was I not crying, but I was walking a lot faster, I felt a lot safer, and I realized just how much information I was getting from the very tip of my cane. And that brought me a tremendous sense of comfort, a tremendous sense of peace in being able to maintain my fierce independence. Now, oftentimes, people ask me about the ball of our canes. This is actually a personal choice. Molly has a different ball on her cane today. You have the, what do you guys call it? Yeah, we call it the marshmallow too. Yeah, so the reason why I have this ball tip is because in New York City, when I first started using the marshmallow tip for my cane, I kept stabbing myself in the gut. And I realized that this ball moved a lot much more smoothly, a lot faster, and I was able to get around without having bruises all over my midsection as frequently. The other thing that people don't often know, and I learned this when I did my cane training, was the red reflective tape on the end of the cane. So in the US, the red reflective tape on the end of the cane is indicative of low vision, meaning that somebody has some vision. They have usable vision. We don't know how much, we don't know how little, but they do have vision that they do use to navigate. And I didn't know that. I always think it's important to share that information. I should mention that if a person has a fully white cane, I remember being told, well, that generally is indicative of full blindness, but I have a friend who has a white cane and he has vision similar to mine. And I said, well, hey, how come you don't have red reflective tape on your cane? And he said, I went to the Helen Keller National Center to do my cane training and they ran out of canes with red tips. So there are exceptions to that rule. Now, a couple years ago, what was it, 2017 maybe? 2017, I was in Mainz, Germany, and I met Molly Watts, who you guys will meet if you haven't yet soon. And I saw that her cane was striped. And I said, hey, Molly, why is your cane striped? That's so cool. I've never seen that. Is that, for decoration? What's the deal here? And she said, actually, in the UK and in Europe, having a striped cane is indicative of both vision and hearing loss, of deaf blindness. And I thought, well, that's brilliant. Why don't we have that in the US? So I went on Amazon and found the cheapest tape that I could, and I striped my cane, and you can tell that it's the cheapest tape because it's coming off like cheap tape, and I gotta fix that. But we decided to make a campaign about it in the US because we really wanted to have it pick up for people with vision and hearing loss. And we posted a cane strength campaign about it online on social media. And it has taken off like whatever the opposite of selling hot takes is. It just did not take off. But if you see someone with a striped cane in the US, maybe they've learned it from me, I don't know. So that's sort of the information behind the striped cane. So in the midst of dealing with all of this vision loss, I learned sign language at the University of Michigan. Again, there was a lot that I was curious about, even if I wasn't yet ready to accept the fact that I was losing both my vision and my hearing. And so I remember learning sign language, and then when I graduated from my graduate program, I went on to work at the School for the Deaf, which was one of the best experiences I could have had because it helped me perfect my American Sign Language. One of the things that people often ask me, and I know that it's different around the world, but in the US, there is a big divide between the deaf community and the hearing community. There's a lot that just obviously doesn't translate, but there's a lot about deaf people that we just don't understand or know. And I remember feeling when I was growing up, seeing people who were deaf, watching them sign and seeing how expressive they were and thinking like, wow, deaf people are so intense. I wonder why they're so intense. Maybe it's because they can't hear or speak, and so, they just have to express themselves in some way. Well, what I learned is that all of the grammar in American Sign Language revolves around the face. So, for instance, if I were to say to you, as a hearing person, that I'm tired, I'd say, I'm tired. But if I were to say I'm exhausted, I might say, I'm exhausted, right? Well, how would you communicate that if you use sign language? So I would say I'm tired, but if I'm exhausted, now, as a hearing person, if you did some of the facial expressions that we use in the deaf community or as a person using ASL, it looks pretty ridiculous. For instance, if I were to say something is delicious, I would say, no, it's delicious. But if it is so delicious, maybe the best thing I've ever tasted, so there are just all of these differences that I thought were so cool and interesting and certainly helped me better understand the deaf community as I became more assimilated. Another thing that I really love about the deaf community that I learned as I was working at the School for the Deaf is how straightforward, how honest they are. And oftentimes, particularly in the US, but in the hearing world, we have a lot of pleasantries. We have a lot of things that we say that we may not actually mean, but it just sounds like the right thing to say at the time. Like, oh, it's so good to see you. I haven't seen you in so long. Let's go grab lunch. Or something like that, or let's get coffee, when really you have no intention or interest in going and having coffee or lunch with the person you've just seen, right? But it makes it a lot easier to get on your day and go to wherever you're going and not have to worry about having a conversation with that person then. And so when I was at the School for the Deaf, I remember one day I'd arrived at school, I think it was like a Monday, and it was after a long weekend, and I was just having a conversation with one of the other teachers from the school. And I remember we were just chatting, and we saw that there was an interpreter and another teacher. They were standing on the other end of the hall. And so we looked, and we realized that that teacher had not been in school for maybe like 3 months. So we decided that we would go and join their conversation. So we walked down, and we made our way to their conversation. And when we arrived to them, I remember the woman that I was chatting with before, she said, "Hi, Ruth, it's good to see you. You haven't been here at school for 3 months or so, and you look like you've gained weight." Okay, so I'm not as familiar in Europe, but certainly in the US, if you see someone you know that you haven't seen in about 3 months, and they look like they've gained a considerable amount of weight, you may say something to everybody you know in common. You may wonder why they've gained so much weight, but you would never say anything to their face, right? You would never say, "Whoa, what happened to you?" And so Ruth said, "Yes, I've been out for 3 months. My husband died 3 months ago, and I've been eating emotionally. I'm so happy to be back in school now so I can socialize and teach with the staff and my students." I mean, as a psychotherapist, if everybody spoke like that to each other, I would be out of a job, right? And it wasn't like she was asking her because she was judging her. She was actually asking her because she was concerned. She hadn't seen her for 3 months. She knew that something had happened. She wasn't sure. But when she told her she'd been eating emotionally, how many people in this room have either eaten emotionally or done something out of emotion, drink, you name it? And it was so straightforward, it was so honest, and at the time, I was so concerned about being in the middle of a conversation like this, to have that realization that this was something that they did because they cared, because it was just so, it was from the source, and it was so refreshing to have that type of direct conversation. And so later on, as I continued to lose my vision, I learned that using ASL was wonderful, but I was having more difficulty seeing people sign. So I'm going to show you what tactile sign looks like. I have to make sure that I play this right. And, oh, thank you. So he's deafblind, and you'll see that he's signing to me. This is tactile sign language. And as he's signing to me, I actually have to back up because of my vision so that I can see his hands, because I'm still learning tactile sign language. He's asking me, well, he was telling me about some information that he'd learned recently about learning Braille. And I told him that I'd heard of it before, but that I knew a really good Braille instructor at the library in New York City. And then he asked me if I had a business card, and I said no, but I can write down the information, and that's what I asked that woman. Ta-da. Okay. So, in the midst of learning sign language and then tactile sign language, I was also still losing my hearing. I was becoming less a part of the hearing world and more a part of the deaf world. I was in this in-between gray area where I didn't really know where I belonged. I had difficulty in both communities because I didn't quite fit in. And so I found out in 2013 that my right ear was a candidate for a cochlear implant. And before I went ahead with the surgery, we did a big search to find all of the hearing aids that I'd used in my time over the years. And these were as many as we could find, and I'm sure that there were more, not to mention the ones my dog chewed up. And so I put them out because it was just amazing to me to see all of these different hearing aids that I had worn over the years before I decided to get a cochlear implant in my right ear. And it was an interesting decision to get a cochlear implant because I never actually believed that I would be a candidate. Remember, with type 3, we're the rarest form. There was no trajectory. It wasn't like there was anybody in my family who'd had it. There wasn't like I knew what my hearing loss was going to look like. But when my right ear was tested, 26% of the time with a hearing aid, without a hearing aid, I could accurately repeat back what was said to me. And with the hearing aid, I could repeat back accurately 28% of the time. So 28% of the time of actually hearing what is said to you is not a lot, right? And so I became a candidate. I decided to go through with the surgery. I'm going to go back to this one. This is the pictures I use for my online dating profile. I got to think of a better joke. I couldn't think of a better one. Anyway, so that's those are some of my blackmail photos. So this was me after getting my first cochlear implant, and then I guess that one was getting the second one. But I later got my second cochlear implant in 2017. I will tell you that my right ear, after a tremendous amount of listening therapy later, and I was an ideal candidate, my listening ability was up somewhere between 92 to about 97%. That's dramatic. It's life-changing. If we had that for vision, it would be a whole different world and ballgame for me today, right? And that's part of why I'm here. But I want to go back quickly because one of the things that having, listen, you guys are the researchers, you're the clinicians. My friend Molly is wonderful with technology and accessibility, but I do a lot more of the emotional piece of what it actually means emotionally to live with a condition that causes you to go deaf and blind. And one of my best friends, Caroline, wrote me a letter when I'd gotten my cochlear implant, and I'm going to try to read it to you, but remember who's reading this. Okay. So it says, "Dear left ear," and this was when I got my second cochlear implant implanted. When you get cochlear implanted, it means that you lose the rest of, at least at the time, and the technology is improving, but I was deciding to lose the rest of my residual hearing. So it meant that without my implants, or my hearing devices, I would be completely deaf. And that in itself is a process, especially for a lot of people in the Usher syndrome community who decide to get cochlear implanted. So, dear left ear, I want to thank you for all of your hard work over the years. I got to know my bestest friend in the world, in the whole wide world, through you. I always, isn't there one right here? There sure is. Okay. Through you, I always knew to walk on the left side. We whispered secrets, jokes, inappropriate comments, and everything in between. You miss a lot of words now, but it's not your fault. I'm grateful for our time together. We're letting you go now to ear heaven with all of the other especially hardworking ears. Know you will be missed. Love, Caroline. Now, that letter was so meaningful to me because it was such a sense of mourning, a sense of loss, of not being able to have any of my normal natural hearing in that ear anymore. I will say that despite going through this process of giving up my hearing, my residual hearing, getting cochlear implanted for me was the best thing I could have done. My left ear, after 3 months, as soon as it became a candidate, I got implanted. After 3 months, sentences in a quiet room, I heard at 100%. That that's dramatic. I don't think there are any more results that can speak greater than that. So what do we have here? A blank screen. Oh, so this is when I was first activated. Is there sound on this?
What are you doing? Are you okay?
So needless to say, it was not my, when I first got implanted, I thought, oh my gosh, what have I done?
Children.
This is the second day after I'd been implanted. She's holding something over her mouth, so I can't see her mouth, which for lip readers is a nightmare.
Children?
Sounds like ginger ale.
What about a sign?
She doesn't see your hand, it's below her.
Can you see, children? Can you see my hand?
Just if
Children?
fingers.
This is the sign for children.
Children.
Yeah. You know
So this is just to show you the process. Now, sentences are always easier to learn because you have context.
what time is it?
What time is it?
Let's go outside.
Let's go outside.
Eat your dinner.
Eat your dinner.
What do you like to eat?
What do you like to eat?
So you hear me speaking higher because at the time, the sound that I was getting access to was very high.
Oh, I
This is
forgot
my
what this feels
second
like.
cochlear implant.
It's so weird.
Can you hear me on that side? Is it loud? Is it
No,
soft?
it's so.
So this was me doing my listening therapy.
Term, deep,
Deep,
vowel,
vowel,
guess,
guess,
Again, she has her mouth covered.
fair,
fair,
which,
So that's just to show you that I killed it. Okay. Anyway, I include that because there's something, particularly in the US, that I like to refer to, and please excuse me for this, but that I like to refer to as inspiration porn. And what that means is that we oftentimes see these videos that go viral on social media or on the internet. We see a child who gets cochlear implanted and activated for the first day, and all of a sudden they turn them on and their face lights up and they hear a sound and the video stops and we think, oh my gosh, my life is so much better now that I know that this person has improved quality of life and hearing and whatever it is. It's sort of that feel-good movement. And the reason why I provide all of this is because it's actually nothing like that. It takes a tremendous amount of listening therapy and work to develop the ability to hear digitally. It's the hardest work I put into anything, and the most important work, I think, in being able to relearn how to hear digitally, but it certainly is not just being turned on and ta-da, I can hear again, right? So, people ask me about all of the crazy activities and sports and stuff that I do, and I mentioned to you that part of the reason why being physically active is so important to me is it helps me manage the stress, the anxiety of going, first of all, deaf and blind, of living in the world that we live in today, but also it gives me a tremendous sense of being alive, of being present. One of the things I didn't mention about tactile sign that I absolutely love is that it forces you to be in the moment. You really can't be multitasking. You can't be on your computer, on the phone, trying to answer a text message while you're communicating with someone, not only in sign language, but particularly on tactile sign language, because you're using your hands and their hands. And it's not inappropriate in nature to bring someone's hands to your chest. And simply a part of the communication process. And the same is true for how I feel about being physically active. I feel so alive. I feel so able-bodied that despite not being able to hear and see as well as others, I do feel this tremendous sense of ability and strength. And I do want to make clear that even though without my cochlear implants I hear absolutely nothing, I do sleep better than anybody in New York City. And so through the process of trying to develop awareness for Usher syndrome, remember we're a rare disease. One of the things that I didn't mention about 1, 2, and 3, which most of you know, we talk about USH2A, is that all of this rare disease, we have subtypes, 1, 2, and 3, and then we have subtypes. So we have type 1A, 1B, 1C, 1F, 2A, 2B, 3A. So it's a community that is really, we're trying to develop and grow in terms of getting diagnosis. The last statistics I heard, there was 400,000 people worldwide who'd been diagnosed with Usher syndrome. I don't know how much different that is at this point. It's something we'd have to sort of look into. But obviously, it's an orphan disease, and the only way that we can get more people diagnosed is getting the information out there. The only way we're going to get more research dollars is by having more people diagnosed, more people available for clinical trials. And so I'm not a scientist, I'm not a researcher, but I sure know how to use my voice. And so I have partnered with, I think we have it in Europe, but Lululemon, which is a fitness company. And I asked them for their campaign photos to make sure that in the photos they could see my cochlear implant to really sort of celebrate and highlight not only disability, but also Usher syndrome, because we are on a mission to get the word out there and to really have people have a sense of community, to know that they're not alone, and also to create greater access, particularly in a world that does not have wonderful access for people with disabilities. Some of the things that I've done, because I'm a crazy person, is summiting Mount Kilimanjaro. That's a whole other story that I won't necessarily bore you with today, but I do know that as I was getting higher up in altitude, I asked my ophthalmologist if she would sign off on me going to climb Mount Kilimanjaro, and she was not keen on that idea. Obviously, being the doctor to sign off on, like, yes, absolutely, she should go climb to, one of the second highest mountains or the first highest mountain in Africa, but certainly going up in altitude, people don't really know what that lack of oxygen does for your eyes. And as I got higher, I would see flashes of light in my vision. And so, but it was only when I would blink. So I remember hiking and trying to keep my eyes open for as long as I could so I wouldn't have to blink, so I wouldn't have the flashes of light. And as everybody knows, you can't not blink. So that was not very effective. But the other thing is that as I was hiking, we had hiking guides, and I was teaching the guide sign language, and he was teaching me Swahili, which, as we got higher, turned out to be a good plan of ours early on, because my cochlear implant battery just continued to die, that I ended up just not wearing it. And this was before I had my second cochlear implant. And so he ended up signing to me, and I would say things back to him in Swahili as we got higher towards the top of the mountain, and it was quite an experience, as you can imagine. The other thing we did was to raise money for UCSF. For the ophthalmologist that I see there, is I swam from Alcatraz to shore, and in the San Francisco Bay. It was probably, it was about 1.5 miles. It took a lot longer than, well, it didn't take quite as long as I thought it might, but I can tell you that swimming in open water versus training in a pool was quite a different experience. And because I couldn't hear anything, I didn't have my ears on, the guy who's in the kayak next to me didn't know sign language, and all I know is that every time I would look up, I would see this. And you're not going to believe this, but I was swimming as absolutely hard as I could. Please stop swinging your arm like that. I know what that means. It means hurry up, and I couldn't swim any faster. Now, what I didn't know, but I found when we got on shore, after I was able to put my ears on, was that if I didn't swim faster, that we were going to miss the opening into Aquatic Park and be brought out to sea. So luckily, I figured out with this that it meant I needed to swim faster. There had been a shark attack a couple weeks earlier, and it wasn't until I actually got in the water that I realized that this is pretty serious, being in open water, and that my, not feeling really afraid of sharks, I certainly did as I was swimming, and I think that helped me not miss the opening to Aquatic Park. So, always got to put more photos in of my dog, because she is just adorable. Okay. So this brings me to the Usher Syndrome Society, and Nancy is going to raise her hand. There she is. So Nancy Quarterman and her husband David and her daughter Hannah. Nancy has 4 children, 2 of whom have Usher 2A. Hannah, who is here with us, who is an absolute light. If you haven't met her, she does so many cool and creative things that I only wish that I had not only the intelligence, but the creative ability to do. So Nancy started the Usher Syndrome Society, and all of the portraits that you have seen around, that is part of the work that the Usher Syndrome Society does. We raise awareness for Usher syndrome around the world. This exhibit has been to Australia, it's been to Mainz, Germany, it's been all over the US, and it's here. And we really try to tell sort of and capture the stories of people with Usher syndrome. We do a lot of different events, including with me, because I like doing strength events. We do various different fitness events that incorporate vision loss and hearing loss. And so this is, this is our trademark, our label. And Nancy will definitely be available to tell you more about the work that we do. And we also fund a lot of research for Usher syndrome specifically. And so I'm on her board. Here's some of the examples of things that we have done. Here's a fitness class we did in Los Angeles, where I co-taught a fitness class. And what's this one, Nance? I can't see that picture. Oh, that was in New York City in Washington Square Park, where we had the exhibit that we have here. That's right. So these are just some of the examples of the work that we do to really try to raise awareness. Here's me breathing in peace, breathing out fear, using my cane in New York City before meeting Molly and striping it. And so one of the things that I never knew that when I came up with this mantra, that how sort of important it was going to be for me later on. And it turns out that I was approached by the Gap for Gap Body, and they asked me to be a part of it because one of the people who's their creative directors read my book and read the mantra. And if you haven't read my book, I highly recommend it. That was supposed to be a joke. Okay. So this was a Gap campaign that we did last year, I believe. And we'll play, hey Alexa, play the video, please.
Breathe in peace. Breathe out fear. There's something so incredibly empowering about accepting who you are. When we love ourselves, whatever shape we take, we can focus on what we have instead of what we don't.
So that was the first part of it, and then it really sort of caught on. And we have for International Women's Day, that's March 8th, so this is now on the Gap website, and Hannah, will you raise your hand? Oh no, yeah, okay. So Hannah, actually, so they took my mantra and they decided for International Women's Day that they would spotlight us around the world with Usher syndrome, and they would make 2 t-shirts, a long sleeve that she's wearing and the tank top that I'm wearing with my mantra on it. And it's helping us raise awareness through a major organization, obviously, company. And so they did a photo shoot with us, and this is now on the Gap website, and we encourage people to buy the shirts and really help us get the word out there. And they made another video. Hannah, she made the design for this, and as you can tell, we had a lot of different trials with it. Ultimately, the Gap decided what they wanted. It had to be on brand for them, but it is sort of supposed to reflect what you see when you go and you do the eye chart at the eye doctor, right? Sort of similar to the EFF, Eye on the Future Forum. And so the video is here.
Rebecca is an inspiration to see someone like me with Usher syndrome able to just move forward and stay positive despite going blind and deaf is incredibly powerful. We as women all have the power to push forward and be our own light, no matter what fears we may have. Breathe in peace, breathe out fear.
And of course, who knew that years ago when I was just trying to live as I was riding my bike, that this mantra would come in handy for us to help raise awareness for Usher syndrome. And so that this will is now actually out and will be shared on social media, and we're hoping to really get more awareness out there for Usher syndrome. So that's sort of exciting for us, right? And this is something that people often ask me about. It's still something that's it's sort of a fun party story, but also very strange. And that is that they're making my book into a motion picture. And apparently Emily Blunt is going to be playing me in the movie. We'll see how that goes, and I'm sure it will be turned into some Hollywood story. But the bottom line is that we are getting the word out about Usher syndrome and really trying to create an impact on the world to not only treat people with vision and hearing loss better, but also to get more people diagnosed, to get them involved in the community, and to have them be available for the types of clinical trials that we're very excited about, that we're here for today and this weekend. So there are different ways to connect with me, and there are different ways to get my book through Amazon, Audible, and I don't know if that translates in Europe, but this is generally made for audiences in the US. Okay. So that's it. I don't even know if we have time for questions. I sometimes like to open it up for questions. Are we alive? Everybody still here? Yeah, okay. So I don't know. I don't know if we want to try to open it up for questions. Someone has a microphone. I probably shouldn't be the one running around to give it to you. Oops. Sorry. Go back. There you go. Okay. Anybody have questions? I don't bite. Anybody? No? Oh, okay. Who has the microphone? Oh, there you go. Okay.
So I noticed you have a very cute dog, but I was wondering, did you ever consider a guide dog?
That always comes up, the question about the guide dog. So I have considered a guide dog, and here's what's interesting about the guide dog is my own ophthalmologist was the one who said, Beck, you got to skip the cane, you got to go right to the guide dog school and get yourself a guide dog. So I called the guide dog school, and they said, actually, you can't get a guide dog unless you're very well versed in using a cane. And it was funny that my ophthalmologist didn't know that. But so I absolutely will get a guide dog when that time comes. I'm worried about keeping that guide dog trained. But one thing I'll tell you about my dog Monkey is that as I've lost, first of all, whenever I come in the room, she gets out of the way. She's learned very early on that she's she's a big obstacle at times. So I try to make eye contact with her to let her know that I see her, and she still gets out of the way. But the other thing is that as I continued to lose my hearing, in the morning when she wakes me up, she used to do this like, which is such an annoying sound and also so cute. But because she wanted me to feed her breakfast, right? And then at some point, she realized that I couldn't hear her anymore after I got implanted, so now she scratches me, which is so cute, right? That she's sort of evolved with me with the hearing loss. But I will tell you also that having her at home, just based on usually when I'm home, and most people with cochlear implants, when we're home, when we're not interacting with the world, the first thing we do is we take our cochlear implants off. I think the same is true for a lot of people with hearing aids. Is that true, Molly? Yeah, Molly, definitely. There's nothing better than even though I still have the tinnitus, I'm used to it now, it's been 20-something years. Excuse me. There's nothing better than, which one's my water? You gotta be careful. There's nothing better than not being able to hear. It is a godsend. It's like silence is my religion sort of thing. But the other thing is just based on how Monkey responds to things, even when I have my ears off, I know what's happening. I know if somebody's at the elevator. I know if they're at the door. I know, excuse me, if her ball is under the TV stand, which is so interesting just on how she responds to me. Does that answer your question? Sort of. Okay. Anybody else? Yeah. I'm sorry.
So, listening to your story, what will you give for it? What type of advice would you give to your 12-year-old self if you could
give some advice right now?
What kind of advice would I give to somebody who's losing sight right
no,
now?
to yourself. If you were giving some advice to your 12-year-old self, what would you say?
Oh, man. That's a good question, right? And I think about that a lot, right? I ask that a lot, don't I? Yeah. Oh, I'm asked that a lot too. Yeah, you know, it's interesting because, so on the one hand, I had to go through this process of all of the challenges and the struggles that I went through to be able to own what was happening to me. And so on the one hand, I'd like to say that, you know, I wouldn't change anything, but I actually would change one thing, and that is understanding earlier on that I am not lesser than, that, that there's not something wrong with me inherently. I think that for a lot of kids, especially who have vision loss or hearing loss or any type of disability or difference, there's a feeling that there is something inherently wrong with you, that you have this vision and hearing loss because there's something bad about you. And I think if I could have understood earlier on, I would have tortured myself less in terms of trying to be something that I wasn't. But I'm very fortunate that my mom exposed me early on, I think, so that as uncomfortable as it was, I had the exposure, excuse me, to vision loss and to helping other people so that it would help me later on when I needed help myself to be able to ask for it. Okay.
What advice would you give? You mentioned you had the two different extremes from your parents, like your dad wanted to shield you and your mom wanted to educate you. We just had a 12-year-old that got screened 2 years ago. Well, he had 2025 2 years ago, 2060, and at the screening he was already at 125. Sister also, she's going in for screening next, but I'm seeing this sweet little 12-year-old boy. You know, you start asking about sports. He swims because you don't need a ton of vision to stay in your, you know, but he came with his dad, and I was just so adverse about his dad was just so sweet, the way he was walking him through getting his first blood draw and sitting through all the testings. And I'm just curious as the child, you know, how, since we deal with a lot of these parents, which you would not prefer, but which was the better, like you said, it was good your mom forced you into. Does that question make sense?
So early on, I remember going to my first Foundation Fighting Blindness conference and seeing all these people with canes and guide dogs and thinking like, oh my gosh, what is this, right? But I also in that moment decided that I was the most sighted of the blind at the time. So the way that, you know, Hannah Quarterman now does for me, like I would help guide people around who didn't see as well. And it gave me a tremendous sense of being needed, of value. I mean, one of the biggest things, and I promise I'm coming around to your question, but one of the biggest things, you guys can see me, hear me, sort of, right? So one of the biggest things I think is being able to recognize our need to ask for help. And that is for anyone, no matter what your circumstances are, one of the most difficult things we have because we are raised to become independent, increasingly more independent. And so to be independent and also need help is sort of a confusing idea, right? And yet, part of how I was able to come to terms with being able to ask for help and acknowledge that I needed it is knowing that I remember, you know, oftentimes, ironically, in my neighborhood, if I see someone with a blind person's cane, I will offer to help them across the street, mostly because it's my neighborhood and I know it very well. But I remember there was an elderly woman who was using a walker, and the crosswalk light was so fast, and there was no way she was going to make it across in time without the light turning red. So I offered to help her, and she used my arm, and I sort of kept my hand up to traffic so they would know that there was people crossing the street. And when we got to the other side, she said, "Thank you very much for your help." And I remember just that connection, the 10 seconds that we spent together walking across the street was to me the essence of humanity, of what it meant to have human connection, of really being there. She was someone who asked for help. I offered, I gave her the help, and it was her asking me for help made me feel needed. It made me remember that I matter. And there's nothing in this world I think we want to know more than that we matter and that we're needed, right? That's part of why we work in helping professions, or we do what we do within our families or any community. And as far as the 12-year-old goes, it's a delicate dance, right? Because I always encourage parents when they first get a diagnosis, you need to go and seek the help yourself first and foremost. Don't wait. I see a lot of parents who go into that woe is me, the fear, and children are highly receptive. They are very aware of what's happening around them in ways that we don't even recognize. And so they pick up on your fear. They pick up on your anxiety. They know when their parents sort of sense or feel uncomfortable about what's happening to them, and they absorb that and feel like it's something that they've created, there's something wrong with them. I think that the more you're able to cope with your own anxiety and fears of the vision loss, the better you are to prepare, you will be to prepare your child. And every family, really is different, because you have a 12-year-old who's trying to develop their independence and be normal, and also trying to find ways of living their lives that will allow them to work with the vision loss. So I think there's so much technology that's accessible now that can help them. So maybe even exposing the kids to that, whether they're ready to pick up on it or not, at least they have the awareness and knowing that it's available. There are a lot of kids who play sports and who do all different things. Certainly when you have strong central vision, actually sometimes it makes for a better athlete because you tune out the stuff around you. But I encourage parents to be with their kids where they are then. Instead of planning so far ahead, really allow the child to be where they are, because we don't know what will happen with research, and hopefully there will be sort of the ability to stop further progression and even potentially restore vision. But more importantly, you have to let a kid be a kid, and be where they are and make yourself available to speak to them. That was a very long answer to your question. Yeah.
Okay, I think
That's it.
that's it. Thank you very much. Let me grab that for you. Oh, I got it. All right, thank you, Rebecca, for that very inspiring talk. I would actually recommend that everybody buys your book. I read it earlier this week, and it's really inspiring. It's really powerful, yes, thank you. And a very personal book. I would really recommend everybody reading it. So, realizing we're a little bit over schedule, the next on our agenda is to take a look into the future. The next part is a presentation about how we see the vision for the future of development and acceleration of the development of medicines for inherited retinal diseases. At ProQR, we plan to become the leader in a new paradigm, of clinical trials called N of 1. And with this methodology, when successful, it allows us to really accelerate the way in which we develop new medicines for inherited retinal diseases. This presentation is going to be given by David Rodman, our Executive Vice President of R&D. Dave Rodman, unfortunately, is a bit under the weather, so couldn't join us in person. So he was kind enough to record a video for us that we will play now. If there's any questions at the end, then let us know. So over to Dave.
Hello, my name's Dave Rodman, and I'm the head of R&D at ProQR. I apologize for not being there in person with you in Paris, but I've gotten some kind of a virus, and I'm under the weather, and I didn't really want to make anybody else sick, so I'm staying home, and I'm speaking to you from my office in Boston. What I'm going to talk about over the next 15 minutes or so is to really give you a flavor of what we think the future is for developing drugs in inherited retinal disease, with a focus on something called N of 1, which means developing a drug for a patient or a series of patients where each patient becomes their own experiment, and each drug is an entirely precision medicine geared to that patient, and how we intend to do that. So what is an N of 1 clinical trial? Well, it's self-explanatory in a way. What it means is that each person who goes on a ProQR drug becomes their own clinical test. If the drug works for them, then it works. And that's completely different from the conventional paradigm, which I'll tell you about in a moment, and gives us a way to develop drugs more quickly and for more patients at lower cost. This idea is not a new one, and in fact, we at ProQR have been working on it for the past several years. But there was a seminal moment in the fall of last year when a report was made of a child who developed an inherited disease that led to seizures. And those seizures were ultimately going to cause severe brain damage. The disease itself, a form of Batten's disease, had a known molecular pathogenesis, and the family identified a physician who, working with scientists, was able to develop a drug much like the kind of drugs that we make, using a small nucleotide that might have the potential to treat their child. Rather than going through a big pharmaceutical discovery program, they made the drug, and within a year were able to test it in the child by injecting it into their spinal fluid. And indeed, soon thereafter, the seizures were improved. And the Food and Drug Administration supported approving the drug for that child on the basis of that N of 1 trial. And now there's great interest in extending this. And so we at ProQR are excited about that because we've been working towards that goal. And now it looks like the regulators are going to be supportive of what we've been working on. So let me just tell you a little bit more about that. Traditional drug development is a very arduous process. It involves many placebo-controlled trials where patients don't necessarily get active drug. They don't necessarily get the best dose of that drug. It takes many stages of development: phase 1, phase 2A, phase 2B, phase 3, which is first in human trials, then dose ranging trial, then proof of efficacy trial, then a pair of very large placebo-controlled confirmatory registration trials. That process can take 10 or 15 years. It costs anywhere from $300 million to close to $2 billion to complete. And it's really stifled our ability to develop drugs, particularly for rare diseases. And so over the past few years, we've migrated to a more modern development paradigm called adaptive trials. And that's the kind of trials that we've been doing at ProQR. For instance, for sepofarsen in Leber's congenital amaurosis, we did an adaptive trial where we made predictions of what the dose would be. We took those doses into patients. We found that the lower dose that we tested was effective. In fact, the second subject in the trial had a dramatic benefit that was, incontrovertible proof of efficacy. And then further, we discovered that the more residual cells that, or function rather, that the patients had, the better their probability of response was in measuring improvement in visual acuity. And so we adapted the trial in that way. And within less than a year from seeing our initial responses in that second patient, we were able to start a pivotal trial, which is ongoing right now. And so we've definitely accelerated the process, probably down to 3 to 5 years. But the next great leap is to get down to that 2 or 3 year point, and more importantly, to be able to develop it for very small numbers of patients who have the same genetic defect. So at ProQR, we've started this year 2 pilot programs to enable that to take place. And the first one in this next generation development platform is called the Skin to Eye platform. And in that program, patients are identified on the basis of their genetics of having a mutation that causes retinal disease that our platform could treat. And so when we identify someone like that, we can enter them in this trial, do a skin biopsy. From that skin biopsy, take stem cells and grow their retina in a dish. And once we've done that, we can test drugs in that screening platform and find the best drug for that individual. Now, the second thing that we've started is a longitudinal study where each of those subjects that we identify by genetics then is followed along, and we measure real-world outcome measures as well as more sort of ophthalmological endpoints that the regulators like to see, and baseline that subject so that by the time their drug is ready, which is probably a year or so from initially looking into the possibility, we've got a good 1-year baseline of their function so that we can do an individual trial and see whether we make them improved from what they would have been had they not been treated. And so that leads us then to our precision medicine platform, or N of 1. So let me get into that just a little bit more for you now. One of the key factors in success for this is we want to be extremely confident that our drugs will work in patients. We don't want to have a lot of failures because we don't want to put a lot of patients through unnecessary procedures and potential risk. And to do that, we use our drug discovery platform, which focuses in on these well-characterized antisense oligonucleotides and other RNA-like drugs. That's a class that we understand very well. We know what the safety is. We know in general what kinds of chemistry works the best. And then because we can then use the patient's own retina in a dish, we can establish, does the drug work? And if it does work, what dose might be the right dose in people? And that takes a lot of the risk out of drug discovery and puts us in a position where we can really make progress quickly. This series of slides that's coming now is titled Establishing Our State-of-the-Art End-to-End Translational IRD Program. So for sepofarsen, a program that started in 2018, we expect to submit our registration and register the drug in 2021. So 3 or so years, that's very quick. In that case, we used the optic cups or the retinal organoids to establish a dose response. We took it into patients, and the second patient in the trial had a dramatic response. And here's just one of those responses in the middle there. You see that change in BCVA, which is best corrected visual acuity. Well, if your BCVA is 2.5, then that means you're really only able to see hand motion. You can't read letters on an eye chart. If your BCVA is 0.5, you're well on the eye chart, and you're not even legally blind. And in this case, you can see this individual went from 2.5 to about 0.5 in less than 6 months. So a dramatic benefit. Now, not every subject in the trial had that big a benefit, but the majority of subjects did have a benefit that was measurable and meaningful. So, so we took that program, we helped build our model for the next program, and I'll show you what that looks like now. Our next program, called QR421A, is for a disease called a disease called Usher syndrome. Usher syndrome is a form of retinitis pigmentosa. This is a slow but persistent deterioration in the retina, starts with loss of night vision, then tunnel vision, and ultimately can progress on to near blindness or complete blindness. Now, this program started in the clinic in 2019. We expect the program to be completed by 2022. So again, a fairly quick program. The trial's in progress right now. Now, an interesting embellishment to our preclinical package here was, rather than just rely on the optic cups, which we did use, we also used a model in something called a zebrafish. Now, zebrafish are a nice little tropical fish you might have in your fish tank, but more importantly, we understand the whole genome of the zebrafish, and it has many of the same genes as humans, including the USH2A gene that we're targeting here. And so in this case, we were able to engineer zebrafish that had the same problem as Usher syndrome patients, and indeed they could not see very well. And we treated them with a zebrafish drug similar to the human drug to target the same mutation. And quite gratifyingly, what we found was that it completely restored normal vision to the zebrafish. So between the optic cups and the zebrafish and other work, we were very confident that we're on the right track. And so we moved into the clinic, and that trial is progressing right now, likely to be some interim data reported soon, later this year. And that led to an improvement in our model, now close to being suitable for N of 1 predictions. To complete the transition over to precision predictions, though, we're adding yet another level of complexity to the preclinical model. And in this case, what we're doing is incorporating a technology where we can actually sense the ability of the retina in a dish to see light. So instead of having to use the zebrafish to see light, the patient's own retina in the dish can see light. So we can characterize what the defects are with the mutation that that subject or that patient carries, design a drug for that mutation, and then bring that drug into the clinic on the basis of the preclinical predictions. And that indeed is our precision IRD platform. Now, in order to make it even more relevant, we're adding a bunch of new outcome measures that are in themselves unique. Wearable technology, so we can measure how people ambulate without a complicated mobility course at a clinic, using virtual reality, and even using artificial intelligence. We intend to expand our repertoire of outcome measures very quickly, try to make it relevant to patients so that there's a real world aspect, but have it be also definitive so that the regulators, when they see a single individual with a response to the drug, they aren't left scratching their heads about whether it worked or not. They will see incontrovertible evidence that it does indeed work. And we're well on our way towards that. And those programs will enter the clinic in 21 to start. And we hope by 2023, we've got a firm foundation and we can rapidly expand into broader and oftentimes less common mutations. So we're very interested in identifying as many of these types of mutations as possible across all forms of inherited retinal dystrophy. So I hope over the last 15 minutes, I've given you just a sense of the excitement we have, where we see the future going. We think we're going to be able to get to the point of making single drugs for small groups of patients in a way that's both rapid and cost effective so that everybody will have access to these drugs if they need them. With that, I'll stop. I apologize again for not being there with you. I wish I could be. I hope you got something out of this talk, and I'm sure my colleagues there can answer any questions you might have. Otherwise, feel free to reach out to me directly at ProQR, and I'll be happy to answer any of your questions. Thanks very much, and goodbye.
So is this on? Yep. So next, I'd like to introduce our Chief Medical Officer, Anise Grash. She's going to talk about probably what has been getting us most excited, our LCA data, and where we really think this is just the future for us of how we can affect inherited retinal disease. So over to you, Anise.
So thank you, Jess. Can you all hear me at the back there? Great, thank you, Andy. So you've heard from Daniel what our vision is for the future. You've also heard from Dave of how we're going to get there in terms of looking at these multiple trials and how actually we are making progress along the way. But my presentation is really going to focus on the here and now. Where are we with the data that we have, and in particular the LCA program? And I'm going to walk you through over the next few minutes some of the excitement that fills ProQR and also around the world and the kind of responses we've had on looking at some of this data. Of course, it's early data, as you'll see, but it is really very encouraging. And I think it's really important for us to think through that even though we've been hearing Rebecca and Molly and others with Ushers, and we're working here in the front-running program with LCA, of course, we are working in these other disease areas. And I think there's a lot to be learned from the front-running program, and the application of those learnings to any subsequent programs is really critical for us. So with that, I'm going to walk you through our sepofarsen data, which is the front-running LCA10 phase 1, phase 2 trial that finished at the end of last year. Daniel showed you this slide already, and it's really that top line. We're already in the phase 3 arena, and many of you are investigator sites in that program. So we're very excited about that, and we'll come back to that in a second. In addition to the top 3 programs where we're running clinical trials, you'll also see on this slide that we also have other programs at the front of the eye, such as Fuchs endothelial corneal dystrophy, and then a whole spate of other programs, not only in Usher syndrome, LCA, but also indeed programs such as Stargardt's that are on the way. So we feel very excited as a company that we're leading the efforts in research in the IRD space, and we have a lot more to come and to offer here. So let's switch gears back into LCA10 now. I'm aware that, of course, there's a wide variety of different personnel here, experts and non-experts in the field. So I'm going to try and make my presentation as widely applicable as possible. Leber's congenital amaurosis is a form of severe retinopathy. It causes blindness. It affects both cones and rods as well at the back of the eye in the retina. The most severe type of retinopathy in some cases. And of course, it leads to blindness at a very young age, as opposed to other syndromes such as Usher's. The onset can be in the first few months of life even as well. As many of the ophthalmologists know, there are typical features of Leber's congenital amaurosis, and in particular type 10, severe and early vision loss, as I mentioned, but also nystagmus, a very fine oscillatory movement that affects patients. There are other features also, such as pupils being affected, and many other features that also are sometimes pathognomonic for LCA. LCA does cover a wide spectrum of diseases. Approximately 20 genes have been identified to cause LCA. And what we're focusing on is the CEP290 gene, the centrosomal protein 290 gene, which is probably one of the commoner causes of LCA10. It is an orphan disease, a rare disease, and in particular, we're looking for a mutation, which is the 2991-1655A2G mutation, sometimes classified as the P69988X mutation. And we believe that at least, and probably conservatively, we think that there's probably about 2,000 patients in the Western world. And what I mean by that is the US and really the major European markets. I think it's compounded by the fact that the epidemiology of this disease isn't so well understood and so not so well reported either at this stage. So sepofarsen is the INN name by the WHO classification. It's not a trade name by the company, and that is a process that my commercial colleagues and others are already working through to identify. The chemical compound that we originated was QR110, so you'll see those names being interchangeable within this presentation. Really, our goal when we set up the first phase 1, phase 2 trial in LCA10 was to try and either restore the vision or prevent further vision loss in these patients who had relatively advanced LCA10. The sepofarsen injection itself is a relatively simple injection now in the ophthalmic world. It's by intravitreal injection straight into the back of the eye. It's not complex. It doesn't need general anesthesia in the majority of patients. Of course, when potentially we're looking at treating kids in the future, there are other factors to take into consideration when application of those therapies are applied. We anticipate that this will be 6-monthly dosing, and you'll see that some of our data does shed some light in that as we look forward into the phase 3 as well. We have orphan drug designation already allocated. FDA has also allocated fast track designation to our molecule. And we are only the second ophthalmic program to have got EMA Prime designation as well. So we're very excited by that. You'll hear the phase 1, phase 2 data results today. And also I'll make a big plug for the phase 3 that's already started today, started earlier this year. But we'll hopefully be having an investigator meeting tomorrow to be able to further dive into the details. So what's the pathophysiology and mechanism of action of the drug? LCA10 really emanates with this mutation causing a pseudoexon formation. That pseudoexon it can result in a defect that ultimately leads to either a truncated protein or there may be some other ways in which that truncated protein or full protein can be degraded within the eye. The protein, the CEP290 protein itself is important because it's positioned in the connecting cilium between the inner segment and outer segment of the photoreceptors, and it actually helps with a lot of protein trafficking and messaging and many other features. And so if you have a defect in that protein, that leads to degradation of that photoreceptor and ultimately leads to visual dysfunction. And that can, of course, lead to blindness ultimately as well. Now, the whole process of sepofarsen is that it masks a cryptic splice site that's there, and therefore you get a wild-type CEP290 protein formed. And that's the whole idea of this drug working within the eye. So this has really led to the phase 1/2 trial. This was an open-label, multiple-dose escalation study. It treated both adults and children, and it used 2 different doses, the 160 microgram loading dose, followed by 80 micrograms maintenance dose, and the higher dose was 320 micrograms loading dose, followed by 160 micrograms maintenance dose. And you can see the schematic there. It was, of course, done in the appropriate safety measures put in place by DMCs, and we enrolled 11 LCA10 patients in total. The age range was between 8 and 44 years of age, and intravitreal injections were, at least one intravitreal injection was given to each one of the eyes of these patients. And we have, of course, representation here today of the 3 key participating centers that were involved. Now, before I dive into the actual data, I'd like to just cover some of the important endpoints that I'm going to mention. And this is probably more for the lay audience, but I want to not apologize in covering this because it's important to understand that in order to fully appreciate the data as well. When you go to your optometrist, you typically have your eye chart, your vision tested through an eye chart, and that's what we call Snellen visual acuity chart. Now, that's different to what we use in research, where we tend to use this chart here, which is the ETDRS, which stands for the Early Treatment of Diabetic Retinopathy Study, a historic study which really helped us put this chart in place and actually made sure that whatever we were measuring was reliable from one study to another. It comprises of 5 letters on each line, and the total of those numbers adds up to 70 letters. With a correction factor, the whole thing adds up to 100 letters, and you get a letter score. And that's how you get annotated in terms of your visual acuity when that's being measured. And the visual acuity is always tested with the best correction that's there. So either with your best correction of glasses or the equivalent. We know that we can also annotate visual acuity in a different format. We can do the ETDRS letters that I've just mentioned here, but also something called logMAR. And you'll hear that more and more in my presentation and also in the literature. And logMAR stands for log of the minimum angle of resolution. And the translation between the two is relatively simple. A 0.1 logMAR is the equivalent to 1 line on the ETDRS chart, or 5 letters on the ETDRS chart. And a minus annotation on logMAR means improvement. Now, there are important guidelines that have been set by the regulatory agencies out there for what is the classification of clinically significant change in terms of visual acuity. And for example, if you're here in Europe, European Medicines Agency say that a 2-line change or a 10-letter change or a minus 0.2 logMAR change, all the same, is a clinically significant change and clinically significant improvement in vision. This sentiment is shared by a lot of ophthalmologists. However, the FDA have a slightly more stringent version of what clinical significance means, and that's by assuming a 3-line change, or 15 letters, or a minus 0.3 logMAR change. And the noise of the assay within this ETDRS chart is approximately 1 line or 5 letters in usually patients who can read on the chart itself. So that's one endpoint that I'll be talking about. The second endpoint that we'll be talking about is this full field sensitivity threshold, or sometimes known as full field stimulus test, FST. This is a relatively simple test that doesn't require fixation, so it's particularly good for patients who have got LCA10, who have the nystagmus and cannot fixate so well. And so it's good for low vision patients in particular. It measures the highest sensitivity in the retina, but is not able to give you any location of where that highest sensitive spot of the retina is. And patients have a stimulus, and they have a button to press a bleep to be able to say that they've actually seen something or not seen something. Typically, you can now, apart from using white light, you can also use red or blue stimuluses as well, stimuli. Red typically measures cone activity. Blue light measures rod activity, although there is a lot of overlap between those as well. And you'll see here in the next slide the kind of tool, typical instrument by diagnosis that's tend to be used, mainly in our trials also. And the patient looks in the dome. They have a stimulus that's shown in there, whether it's color or white, and then they have a pad where they can indicate whether they've seen something or not. And the last investigation or endpoint that I want to mention is the mobility course. The mobility course is often known as the MAZE test, or the multiluminance mobility test as well. And this was made famous by another company called Spark Therapeutics, who used that as a primary endpoint to be able to get their drug, Luxturna, approved as the first gene therapy approval within the inherited retinal disease space. So that was a very exciting moment for all of us in the space. And with the help of our colleagues at Aura, we've been able to develop this alternative course, which gets to the same heart of the essence of what we were trying to get to, which is that a patient navigates themselves through a series of different obstacles in different lighting conditions as well. And therefore, we can try and measure how well they do with time or with errors that are caused as you navigate through that test. And you can see on the right-hand side that there are a series of 19 different courses there, 20 levels, with different luminance levels and different hardness of the courses also that a patient navigates through. And so these are the 3 important investigations and endpoints that I'm going to be particularly focusing on. Just to say that this phase 1, phase 2 data set, because it just finished at the end of last year, the trial, we're still doing a lot of analyses, but you'll hear today now the high-level highlights of that analysis so far. And we'll be sharing much more information at ARVO, and then in any subsequent manuscripts that will follow as well. So altogether, we had 12 patients screened, 1 screen failure, 11 patients were enrolled into the study, 6 patients were enrolled into the low dose, the 160 by 80 microgram, and then 5 patients were enrolled in the mid dose there. There was a high dose that was predicted, but you'll see from my data that actually due to the benefit that was seen and also the safety elements, there was no need to escalate at that high dose. And all of these 11 patients completed the study, and many of those have rolled over into now what's known as an extension study as well. In total, we have achieved over 4,000 subject treatment days at these 2 dose levels. So it's an incredible level of experience and safety that we've amassed already in terms of gaining information and gaining data to be able to really help us move forward and think about our phase 3 trial. The baseline demographics are summarized here in this table, rather complex. I'll draw your attention to the right-hand side margin, which highlights the 5 patients that were in the high dose, or the 320 micrograms loading and 160 microgram maintenance dose, and the 6 patients that were in the low dose, the lower dose, 160 by 80 micrograms. Also, you'll see that in terms of the genetics of these patients, of course, everyone had to have at least one allele with a CEP290 specific mutation. But there was one patient at the bottom, the 0305, as that person is noted, 14-year-old female girl, who actually had a biallelic, a homozygous mutation with this particular disease. And the reason why I mentioned that is that that patient actually has relatively good vision, 0.63 on the ETDRS, or logMAR and on the ETDRS chart. And we'll see actually some really interesting data as a result of that patient being treated with the drug. I'll also take a moment to highlight that within the higher dose, the 320 micrograms, 160 microgram group, you'll see that 3 patients had light perception vision. So the majority of those patients in the upper dose had very poor vision to start off with. So these are the top-line efficacy results, the primary and key secondary endpoints, and I've pooled the data set here within this chart. The yellow highlighted row at the top is the best-corrected visual acuity, 11 patients in total, and these are the logMAR data that you see here. Typically, you remember the logMAR clinical threshold with the FDA is minus 0.3, or 3-line improvement. This is the mean change from baseline out to 12 months, and you can see the treated eye data as well as the fellow eye untreated data as well. And you can see that in the treated eye, as a result of the treatment, there was a minus 0.55 logMAR change or improvement. So this is about 5.5 lines improvement in the treated eye, as opposed to the untreated eye, where there was a minus 0.12 improvement, about a line improvement, which you would expect as the noise within the assay, as mentioned before. So this is really very important data for us at this very early stage in small numbers of patients, yet profoundly important as we think about how this drug could be working. This is further substantiated by other data and other endpoints, and that's what really is particularly exciting for me as an ophthalmologist, to look at this data and think about whether there is consistency there or not. Because if you look at the red FST and the blue FST, both of those move in the right direction as well. We have a minus 0.91 improvement in red FST, minus 0.79 improvement in the blue FST. And both of these are directionally moving in the same way and are clearly differentiated from the fellow eye changes that are going on. There is also mobility course improvement as well. I would say that the mobility course, which is run by Aura, is actually the subject of a separate validation study that's ongoing in parallel, and therefore we believe that we can further optimize the mobility course, and I'm sure you might share those sentiments with me as well. If we now focus in on the 160 by 80 microgram, the lower dose, this is the target registration dose that we want to take forward into phase 3. And you'll see that the same messages are also evident here, but actually more profound. So the BCVA improves by minus 0.93 logMAR, the equivalent of about 9.5 lines, roughly on an ETDRS chart. You can see also improvements in FST and blue and red FST in particular, and the mobility course levels are more improved in the treated eye compared to the contralateral eye, the fellow eye. So this is highly exciting for us and actually very reassuring that this dose is the one that we're taking forward into the pivotal trial. A little bit more detail on this data to come now. So as we focus in on this lower dose arm, excuse me, you can see this waterfall plot here of the change from baseline in visual acuity on the y-axis. You can also see the baseline VA values at the top here. So for example, the first patient that had the biggest improvement of minus 0.266 logMAR change had a baseline value of logMAR 4, which is light perception. So this is quite interesting that one patient with light perception had such a significant improvement. There was another patient with light perception at the other end in this low-dose arm that did not show an improvement from change from baseline. But you can see that the thresholds there are given for the US and the EU for the relative improvements for vision. And 4 out of the 6 patients improved if you were looking at the minus 0.3 logMAR change, and 1 extra would have improved according to the European classification as well. The same data for the upper dose, the 320 micrograms loading and 160 microgram maintenance dose. You can see here, just to remind you, that 3 of the 5 patients had logMAR 4, which is the light perception, and 1 out of those 5 patients responded by improving by more than 0.3 logMAR change. Here's another way of summarizing the entirety of the data. This is the mean change from baseline, looking across time, and looking at all 3 parameters in one. So this is the target dose, the lower dose, 160 microgram 80. And you can see the BCVA improvement here. The arrow down shows you that if the line is going downwards, that's improvement. The blue-green line here is the treated eye. The yellow-orange line is the contralateral or fellow eye. And you can see that the treated eye improves significantly there. And even as early as month 2 to 3, you see a big shift in improvement within that group. And clearly there's a separation there that's developing across the 12 months time point. If you then look at FST, again showing that less sensitive is at the top. If you go downwards, it's improvement. You can see that both red and blue FST is improving in the treated eye, which is the bolder of the 2 sets of lines. The lighter sets of red and blue lines are the fellow eyes, or the contralateral eyes. And again, you can see the delta and the separation developing very nicely with time. And that's the same also with the mobility course, where now upwards is improvement, just to keep you awake. So this is treated eye again in the blue-green, and the yellow-orange is the untreated eye, the fellow eye. And you can see again there's a marked improvement in the mobility course, even though that's not quite ready for prime time yet. Nonetheless, we were seeing enough data there to be very encouraging for us. Now, what about the entirety of the subjects? Here's all of the subjects mapped out in the same 3 endpoints that we're looking at. And apologies for the very small print here, but I'll point the details out for you. This is the best corrected visual acuity chart here, the FST chart in the middle, and you've got the mobility course chart on the extreme right. And you can see that the best corrected visual acuity moving downwards is an improvement. The orange line here, this time, is the treated eye. The blue line is the contralateral or fellow eye. And across the board, you can see that across all of the subjects, there was an improvement noted. There was a short blip of worsening of visual acuity at the month 9 time point, and that coincides with a couple of patients who had cataract formation. And you'll see that that's a feature of this drug from a safety point of view in a later slide. But once these cataracts were removed, the improvement of vision, again, was maintained out to 12 months. In this entirety of the subjects, you can see the delta and the difference between both red and blue FST, solid lines in the treated group, and the slightly shaded line here, which is the fellow eye, contralateral eyes. And also you can see the delta and the difference between the treated eye here in yellow-orange compared to the blue line, which is the fellow eye. So that's the entirety of the group. If we look at the mid-dose group, what happens to the data there? And this is very interesting. So you'll see here in terms of visual acuity, and I will just remind you that 3 out of the 5 patients had light perception at baseline. And so you'll see that there is maybe something happening in terms of the visual acuity. There's this big blip upwards, which is a worsening of visual acuity, and then an improvement. And as you would have guessed, that's cataract formation in some patients. And then as the cataracts are removed in the study, the patients go back down to their previous value, and so on. It is really noteworthy that in these patients who have LP as well, that actually there's consistent FST improvement, though. So here are the solid blue and red FST lines in the treated eye, and the slightly paler colors are the fellow untreated eyes. And so even though we suspect that probably the high dose, the higher of the 2 doses, didn't have as great a benefit to the eyes, it's clear from looking at the FST chart that actually there was still something going on there, even in the patients who have light perception. So clearly there is a lot more to the light perception patients that we've clinically diagnosed as light perception, but maybe there are various grades of light perception out there. And so that's still for us to be defining. And of course, further analyses are ongoing in this particular area. Here is the interesting homozygous patient that I mentioned to you earlier, the 14-year-old girl. She had a 13-letter improvement in her vision. You can see that here on the left-hand side with the BCVA chart. And this was across a 12-month interval, and it was just with one single dose of that low-dose 160 microgram loading, and that's all she had. She did not get any further maintenance doses. So in that homozygous patient, it seemed like that one dose has still got a maintenance of the benefit there. And this patient will be followed up in the extension study and has still, we know, up to the last visit, had a maintenance of the benefit just with that one single dose. She's coming up for a further visit in the next couple of months or so, and so it'll be very interesting to see that data in the subsequent 002 study, which is the extension study. You can also see that she had an improvement in her FST as well. Blue and red FST improved. Downward motion is improvement. And she had a 7 mobility course levels improvement in the mobility testing as well. So really a classic case of improvement across all of these different measures. And so that was very encouraging. Now, what about safety? That's clearly very important. We've realized that actually the safety overall can be divided up into cataracts, formation of cystoid macular edema, which is typically mild, and subclinical retinal thinning. And these are really the kind of target toxicities that have been identified before in the toxicology programs. If I take one of these at a time, with regards to the cataracts, we have found that 8 out of the total 11 cases have now developed cataracts. And this is divided up such that half of the patients, out of half of the eyes who had the low-dose arm, that's the 160 by 80 micrograms, had cataract formation. And all of them, 5 out of 5, out of the mid-dose arm, developed cataract formation. Typically, this was dose-dependent, and we can see that actually the onset of the cataracts was different compared to the low dose, comparing it with the mid-dose. So that if you look at the low-dose arm, typically the cataracts were coming on between the 8 and 12-month time range, but with the higher dose arm, they were coming on much earlier. And of course, in those patients who had cataract extractions done, and in those patients who actually had an improvement before that, they had a restoration of their improvement in vision back to their pre-cataract stages. So that's reassuring that there's nothing odd about these cataracts or the removal of these cataracts that hinders any potential benefit that could be there longer term. With regards to cystoid macular edema, typically it's been described as mild. It's occurred at one center only, 2 cases so far, and both of these cases are in the mid-dose arm. We have not seen any in the low-dose arm. These cases have started typically around the 3 to 4 month duration phase, and have typically responded to just topical dorzolamide or other similar drugs. Both of these cases of CME are either fully improved or improving at this stage. And so we really don't, at least from an investigator point of view, there isn't a lot of concern with regards to that affecting the overall vision. Importantly, of course, they happened in the mid-dose arm only, and none have occurred in the low-dose arm. And that's the same with the retinal thinning, which is really subclinical, delineated really by the help of our reading center, who look at the actual micron change that's going on of the level of retinal thinning. These patients are also 2 in number, and both occurring in the mid-dose. None have occurred, no occurrences like this in the low-dose arm. And in fact, one of those 2 patients who had the subclinical retinal thinning had actually an improvement in their visual function. The other patient is a light perception patient, so it's very difficult to be able to work out what happened as a result of that retinal thinning. And the onset was between 3 to 10 months, so there's quite a range there. And the retinal thinning appears to have stabilized after the month 3 time point onwards. So here are the safety summaries in a slightly different way, just to highlight that the cataract surgeries, 2 out of the 3 findings had surgeries in the low-dose arm, and both of these patients had a restoration of the visual gain that they had prior to the cataract formation. In the upper dose arm, there's been 4 surgeries out of the 5 cataracts, and complete recovery for all of those 4 subjects to their pre-cataract beneficial level of the visual acuity. Altogether, 4 findings in 3 individuals for the retinal findings, accumulating as a result of the CME and also the subclinical retinal thinning. So, as a result of the initial improvement in the phase 1/2 study, the investigators at that stage really appealed to us to see if we can actually do an analysis of that data set. And we published the 3-month data set in Nature Medicine. And as a result, a downstream result of that, we approached the FDA to say, well, what do you think to this data set? Is this enough for us to be able to then start a phase 3 study? And they looked at the data set and they gave us the green light to do that. And that's why the phase 2/3 Illuminate study is up and running since then. And I want to share with you the trial design here for the phase 2/3 study. This has had both European and FDA input. And so, luckily, hopefully, this will be acceptable by both agencies. This is a 3-arm study. As many of you would probably be aware, if you've dealt with the FDA, that the FDA always like to have 2 treatment arms in a phase 3 study. The target dose arm, which is the 160 loading dose and 80 microgram dose, is the one that's the lower dose in our phase 1/2 study. So that's the one that we brought forward. And the FDA like to have an even lower dose to act as a masking arm, so that if physicians who know that they may be injecting a patient with a drug are injecting, at least they would be masked to not know which particular dose they would be injecting as well. So there is an element of masking involved there, and the FDA are particularly keen on that kind of trial design, and that's the design that we've adopted here. So you'll see that the second lower dose arm is 80 microgram loading dose, subsequently followed by 40 microgram maintenance dose. The FDA do not expect to see any kind of dose response here. We're really looking at the target dose being the 160 microgram, 80 microgram dose. There is a sham procedure, no penetration of the eye globe. That also is the 3rd arm of this triad. We'll be following out these patients for 12 months with a loading dose, and you can see that up at the top here. The loading dose at 0-month time point. There'll be a 3-month interim analysis for sample size re-estimation and a subsequent maintenance dose given at 3 months. And then it's a 6-monthly schedule as annotated by the golden stars there, right through to the end of the study at 24 months, with a 12-month evaluation point of the primary endpoint, where we can potentially file for this drug, if need be, for potential approval. You'll also see some blue-green stars there from the 12-month point onwards. This is really the opportunity for us to be able to dose the second eye of the patients so that if the benefit risk is appropriate, especially for that patient, but at even a study level, then we get an opportunity to be able to even treat the second eye and generate some very valuable data that we can present in our dossier as well. We do aim to crossover patients who may be allocated into the sham procedure arm for the first 12 months to crossover into one of those 2 treatment arms in a randomized manner. We hope that the benefit risk still remains positive for that to still occur. And you can see the details here at the bottom of the details of the actual trial, including some of the sites that we have here present today. Our target is 30 patients. There's an age group which is greater than 8 years of age, and the reason for that was really an FDA requirement, again thinking about the cataracts and potential cause of amblyopia, and that's why they urged us to really look at a greater than 8 years of age group. What we will do, of course, in the future is look at a pediatric trial of patients less than 8 years old at a subsequent stage to really bolster up the data and information we have across all different age groups with this particular compound. And you'll see also that here is the primary endpoint, which is visual acuity, as measured by ETDRS chart, the Berkeley Rudimentary Vision Test, which is the off-chart measurements that we tend to use, and the primary endpoint time point is 12 months, with some very key secondary endpoints. Some of those I mentioned already today. So really, overall, the conclusions and the snapshot that we have from the phase 1, phase 2 study so far is that we have positive benefit risk for safety. Really, it was a safety trial, but we were lucky to see some of the efficacy readouts that we've got already, and of course, they were very positive. We feel that the target dose has been identified, and now we've moved that target dose into the phase 3 element. We believe that we've also identified the primary endpoint, which is hopefully acceptable from a regulatory point of view. Historically, of course, we know what the threshold is for clinical relevance for those particular endpoints. We believe that we've seen strong and significant and durable responses in these target dose out to 1 year and beyond as well as we look into the extension study. And of course, that forms the basis of the primary endpoint in that phase 2, phase 3 study and gives us that confidence in the phase 2-3 study as well. We believe we've also identified the target population now as well, and that's really those patients who have hand movements or better, and we believe that those patients respond the best. Do perception of light patients improve or benefit from our drug? We believe so also, but actually from a trial point of view, it's not going to be easy for us to show with perception of light because it's such a heterogeneous population out there. And we will share some further data, and you saw some of that data with the FST readout of why we think that even some of those patients could benefit potentially in the future. But more data to come on that point. We believe that the mobility performance is going to support the BCVA, and like I said, with the help of our colleagues in Aura, we are validating that in a separate study. And the 6-monthly dosing schedule has also been validated within this first trial as well. So with that, I'm going to conclude. And I'll ask you if you have any other questions for me. Thank you.
Two questions.
Katrina.
So you told that the second group, the 80-40, is basically for the FDA, and you don't expect any efficacy. Did I get it right?
You heard it partially right. The 80-40 is mainly driven by the FDA, who wants a second group.
We have 2 placebo groups, 2/3 placebo groups. So why don't the patient cross over to the efficacy group, all of them, in the second year?
So it's interesting, Katrina, that, of course, we have never tested the 80-40 group. It could be that that is efficacious. And so we don't know that. There's just not been anybody who's tested that. If you look at some of the optic cups and some of the organoid modeling that we do, there is an argument to be made that actually there might be some efficacy seen there. But of course, unless we went through another phase 1, phase 2 study exploring 80 micrograms loading and 40 micrograms maintenance, we won't know. So really, the essence of that dose, that arm being there, is purely masking at this stage. If we do get benefit, we'll have to look at the benefit and the risks and safety profile as well and make a judgment call there. But there's an equal distribution between the target dose and also the lower dose and then also the sham procedure as well.
So do you even know by heart which effects were on the organoids in this group, or you don't have this data?
I can share that data with you, once I get that. Thanks.
Maybe one more question. Anise is here all weekend, so happy to answer. Yeah?
You probably know the question that I'm going to ask, Anise. It's one that I always ask. You had any patients involved in the design of this trial? It's a quick answer. Probably.
Yeah, the simple answer is yes, of course, and we always continue to get patient participation in this. And so, Andy, who runs the patient steering committee also, is instrumental in all of the activities that we do.
Thank you. Well, Anise will be around if there's any more questions. I know we're supposed to be on coffee break. We're going to abbreviate our panel. If we can go to the next slide. And I'll just ask our panelists to come up while I introduce them and introduce this topic. So we'll cut this down to about 15 minutes, and then we'll break for coffee. So Fritz, I see you hesitantly coming up. Please come up on stage. So welcome back Rebecca, who was introduced earlier as our keynote. Professor Isabelle O'Doe, she's a clinician scientist and a professor at Keynesville, a group leader at the Department of Genetics. She's also a principal investigator on our LCA and Usher trial. We have Dr. Fritz Asmuss, who's our Vice President of Clinical Development at ProQR. He's the medical lead for all of our clinical trials. And Mike Schwartz, who has led the LCA10 program at ProQR since its beginnings. So just while they get settled, the topic of the panel is demystifying clinical trials. And as we know, the environment for IRDs and clinical trials is fairly new. So lots of information out there that needs to get out there. So we just wanted to bring these panelists together to give us their perspective on the topic of clinical trials and IRDs. So I'll just ask a few questions and then I'll open it up to the audience just to get us started. And one thing I found really interesting was, Rebecca, you had written a blog post for our Iron the Future forum, and I had asked what would make you consider participating in a clinical trial, because you have not yet participated in one. And you said it was difficult for you to answer because you've been told since the age of 12 that there would be a treatment in 10 years, and it's been 30 years since then. So if you don't mind just kind of talking about what you feel the responsibility of the medical community is in educating on clinical trials for someone with an inherited retinal disease.
Yeah, you can hear me? Yeah. All right, I'll try to be quick. I know everybody probably has to go to the bathroom. So I will say that for me, I think that historically, because I've been doing this for a while, the medical community has been, and this is not to all of you, but just sort of generally, has been irresponsible in the way that they have relayed information and communicated hope to people living with retinal degenerative diseases. Because remember, when you're going blind, there is nothing you hold on to more than hope. And so although you're preparing or you're doing everything you can to make the changes and adjustments that you need to adapt to vision loss, you also live and do so much just living with that hope itself. And so when I was 12, I was told in 10 years there would be treatment. And 10 years later, I was told in 10 years there would be treatment. And I think that now we live in a world where there's social media, there's the internet, and so there's a lot of access to information and inaccurate information too. And so I think it's just very important for the medical community to talk about the promising research they're doing, but also be very realistic and even honest, if that's possible, about how soon realistically it might be available and what some of the obstacles are, in addition to how encouraging it is.
Thanks for that. And maybe, Isabel, if you want to follow on that, just as a physician and ophthalmologist that also conducts a lot of clinical trials, kind of what your thoughts are on how to better communicate with patients.
So the dilemma is always being excited. We've been waiting for so long, and when the clinical trial starts, we are very, very excited. The team is excited. And then we also have to consider that it's a clinical trial, it's not a treatment. So we have also to explain that in a very unemotional way to the patient. Of course, we want the patient to be part of the trial, but we also want to have realistic expectation from that trial. And I think sometimes it's quite difficult. And I think my most difficult question that is always asked, especially when it's dealing with a child, is, if it were your child, would you do it?
I always ask that question.
And maybe just for Mike and Fritz, as representatives of ProQR up here, and we feel like we have exciting data, although it is still experimental. So maybe just your thoughts on what our responsibility is as a company, or how we communicate both to physicians and patients about these emerging treatments.
Yeah, I believe Isabel is completely right that we have to do a good job and an intense job in educating about what clinical development is about, and that not the very first patient in the very first study is expected to have great response, that this is a more coordinated effort. Of course, in cases like in the sepofarsen trial, if we see these responses, then this is great and everybody's excited and passionate about it, but we also have to manage expectations. First of all, these approaches have to be safe, so we don't want to put anybody at risk in even leaving our trials worse than they entered it, and that's the ingoing position. And on top of that, doing good. I think Dave Rodman mentioned that this still in traditional development takes considerable years, but we're working really to transform our passion also smartly into really speeding up that process, and that's one of our core ambitions to deliver on that.
Yeah, and I think this type of forum is important for us as well, where we really have an opportunity to bring the patients and the physicians, patient advocacy groups, researchers like us and companies like us. I think once we're aligned, we'll try to do our part of it, of trying to give you guys the right information at the right time. We're trying to really expedite everything we do, but the goal really is to get these medicines to patients as fast as we can.
And with that, I'll open it up to the audience to make sure people have an opportunity to ask any of the panelists questions about clinical trials. Are there any questions?
Coffee break is too tempting.
Hi. I have a vested interest in this question. So, regarding clinical trials involving babies, no? I'm wondering which is, let's say, given the momentum around Leber congenital amaurosis and the fact that, if I understand correctly, the early you start using the sevoflurane, the better are the conditions. Which are the main obstacles, the main hurdles in starting trials with younger babies?
So I can take that. Yeah, so we actually are starting a trial this year in the pediatric population from about 4 to 7 years old. We just had an advisory board with many pediatric ophthalmologists to help us out with that design, so we are kicking that off. I think ideally, I'd love to inject newborns because this is a disease that starts there. It's more complicated than that. It seems like a simple thing, so I think that's our hope, and we'll continue to figure out how to do that. But in the short term, we will definitely plan a pediatric trial with a younger population this year.
And maybe to add one thought that I picked up from Rebecca from the cochlear implant. So specifically, if you have low or no vision, it may also take a training effort because you don't get the hearing overnight. So why would you get all the vision overnight? And we know about these functional MRI studies that the visual cortex has to develop, and there's a certain sensitive phase for that. So all of this has to get together with academia. We have to study these aspects to really then deliver an optimized therapy, and the drug is one component, but it's certainly a more complex system than which needs partnership of all involved stakeholders.
Any other questions?
I'm just going back to my, just because I'm not well versed in this area, but going back to my high school biology, but I believe you get one gene from each parent. So if I have one mutated gene from mom and one mutated gene from dad, and I have, let's say, Usher syndrome type 2, but I don't have the A, and you come up with a treatment that covers one of the two mutated genes, is that something that you're looking at for the future, that you're able to treat, partially treat some of the conditions because you're at least tackling half of the problem? Or am I missing the boat on something here?
I don't know if our expert genetics person wants to answer that. Isabel?
I can attempt to answer. Actually, the hypothesis is that in some condition, if you express a certain percentage of a normally functioning proteins, it's enough. You don't need to express 100% of the normal proteins, but some percentage may be enough to reverse the phenotype, the detrimental effect.
And it would be optimal and also targeted that we get closer information with the retinoids and all these preclinical models to predict that better, because currently we are still applying this, but they are not fully validated, so there is still some uncertainty if we are on target for the dose finding. If we are applying these models, then maybe we, and hopefully we're getting better in being right on target in a shorter period of time.
Maybe we'll just do one more question if there is one out there. No? Okay, well, thank you very much. This concludes the main forum. If we go to the next slide, we are going for coffee break, but I just want to direct you to what you'll do after coffee break.